Good morning, afternoon, or evening, depending on when you're viewing this presentation. Today, I, Chad Gibson, along with fellow classmate Jessica Marsh, will be presenting to you Causal-Comparative Research. We hope that you will find this information educational as well as informative. So just what is causal-comparative research? By definition, this is where the researcher attempts to determine the cause or reason for existing differences in the behavior or the status of groups or individuals. In other words, the key characteristics is that it takes established groups that are already different on some variable, and the researcher attempts to identify the major factor that has led to this difference. Such research is sometimes called ex post facto, which is a Latin term for after the fact. And this is because both the effect and the alleged cause have already occurred and must be studied in retrospect. Causal-comparative research is also a quantitative research method, and beginning researchers often confuse causal-comparative research with both correlational and experimental research. There are two basic approaches in causal-comparative research: retrospective and prospective. In retrospective, this is where the researcher starts with the effects and then investigates the causes. And this is most commonly found in educational research. The prospective causal-comparative starts with the causes and then investigates the effects. As I mentioned in a previous slide, causal-comparative research is often confused by beginning researchers as both correlational and experimental research. In the next 4 slides, we're going to take a look at some similarities and differences between causal-comparative, correlational, and experimental. First, let's take a look at the similarities between causal-comparative and correlational. Both research methods lack the use of variable manipulation. A common misconception held by beginning and even more experienced researchers is that causal-comparative research is somehow better or more rigorous than correlational research. Perhaps this misconception arises because the term causal-comparative sounds more official than correlation. And we all have heard this research mantra: correlation does not imply causation. In fact, however, both causal-comparative and correlation methods fail to produce true experimental data. Both of these researches do a great job of identifying variables that are worthy of experimental investigations. Now let's look at some differences between causal-comparative and correlational. In causal-comparative, it attempts to identify cause-effect relations. Also in causal-comparative, it involves 2 or more groups in one independent variable. Finally, it focuses on the differences between groups. With correlational, it does not even try to identify cause and effect relations. And what we also find is that it involves 2 or more variables in one group of participants. And finally, in correlational, it focuses on the relations among variables. Just like with correlational research, causal-comparative also has some similarities with experimental research. First, they both attempt to establish a cause-effect relations. Secondly, both involve group comparisons in their studies. Just like there was differences with the correlational research, Causal comparative and experimental also has their differences. One of the major differences is that in experimental research, the independent variable, the alleged cause, is manipulated by the researcher, whereas in causal comparative, the variable is not manipulated because it has already occurred. In other words, in an experimental study, the researcher selects a random sample from a population and then randomly divides the sample into two or more groups. In this way, the researcher manipulates the independent variable. That is, the researcher determines who is going to get that treatment or what treatment. In causal comparative research, in contrast, groups are not randomly assigned to treatment groups because they are already in established groups. For instance, like male, female, college graduates, non-graduates, things of that nature. At this point, one may be wondering, what are some independent variables that are investigated in causal comparative research? There are 5 that I like to present. 1, organismic. 2, ability. 3, personality. 4, family related. And finally, 5, school related. Grouping variables in causal comparative studies cannot be manipulated, should not be manipulated, or simply are not manipulated but could be. Indeed, it is not feasible to manipulate an independent variable for a large number of important educational problems. For instance, researchers cannot control an organismic variable, which is a characteristic of a subject or organism. A couple of the most common organismic variables are age and sex. Additionally, ethical considerations often prevent manipulation of a variable that could be manipulated but should not be, particularly when the manipulation may cause physical or mental harm to the participant. If you look at this figure, it shows grouping variables often studied in causal comparative research. These variables are used to compare 2 or more levels of dependent variable. For an example, a causal comparative researcher may compare the achievement of a first graders who attended preschool to the achievement of first graders who do not attend preschool. In each case, pre-existing participant groups are compared. Now let's look at the steps in conducting causal comparative research. There are 5 of them. Just like any other research, the first step is develop research questions. An example would be like, what is the difference between full-day kindergarten and half-day kindergarten students in mathematics and reading abilities as they progress through elementary school? Next, you should select 2 groups that differ on the variable of interest. You need to try to get at least a minimum of 15 people in each one of those groups. The more similar the groups are on everything but the variable, the better for the research. Thirdly, determine the groups based on the background variables of the individuals. These are things like age, years of experience, gender, and any prior knowledge that may be obtained and examined for groups being compared. Remember, the more similar the 2 groups are on such variables, the more homogeneous they are on everything but the variable of interest. Fourth, you need to have control procedures in place. And we're going to talk about things like matching and comparing homogeneousness in groups and subgroups and analysis of covariance. And again, this is to help to identify those inequalities that may come through during the testing. Lastly, 5th step, you need to analyze and interpret the data using descriptive statistics and inferential statistics. And we'll talk more about each one of these a little bit more in detail in the next few slides. On this slide, you see a table, and it shows the basic causal comparative design. We have a case A and case B, and both have an experimental and a control group. However, in case A, one group possesses a characteristic the other one does not. But if you look at case B, Both groups have the characteristic, but to a differing degree or an amount. So, for instance, like in case A, you may have an example with a child that has brain injuries with a child that has no brain injuries. However, in case B, it's a comparison of two groups, with one group composed of individuals with strong self-concepts and the other composed of individuals with weak concepts. In both case A and case B designs, the performance of the groups is compared using some type of instrument. Causal comparative research has some threats to validity or some weaknesses. First, if you remember, we talked about it has that loss of ability to randomize or manipulate single variables. Secondly, selection biases of the test subjects can harm research. We need to make sure that you're randomly selecting. In other study designs, random assignment of participants to groups is probably the best way to try to ensure equality of groups. But random assignment is not possible in causal comparative studies because the groups are naturally formed by the start of the study. The last thing that we need to look at is location, instrument used to conduct the research, and the loss of the subjects can all harm validity. And here we need to talk about things like control and what procedures we need to have in place to ensure that we take whatever's inequitable and make it equitable. So in the next few slides, we're going to talk about things like matching, comparing homogeneous groups, and analysis of covariance. One type of control technique that is used with causal comparative research is this idea of matching. Matching is a technique for equating groups on one or more variables. And what a researcher tries to do is that if a variable likely to influence performs on a dependent variable, they may control for that variable by pairwise matching. And what pairwise matching basically does is that, say, for instance, a participant in one group with an IQ of 140, they would be matched with an IQ at or near 140 from another group. Now, pairwise does have its problems. The major problem with it is that obviously if you don't have anybody that matches up and has a low or high IQ, they're probably going to be eliminated from this study. And then if you take on the fact that if you look at two or more variables simultaneously, it becomes even a bigger problem when you're trying to match these participants. So matching is just one way that if it's clear cut that you can use as a control method. Another way to control extraneous variables is to compare groups that are homogeneous or that are alike. So let's think for a moment on IQ. IQ has a huge range. But what if I, as a researcher, I just want to look at those with IQs between 90 and say 120? Especially if IQ is considered an extraneous variable. Well, this procedure will lower the number of participants in the study, and it'll also limit the generalizability of the findings because the sample of the participants include such a limited range of IQ. A more similar but satisfactory approach is to form subgroups within a group to represent all levels of control variables. For example, each group may be divided into subgroups based on IQ. So for instance, say high is 116 and above. Average is somewhere between 85 to 115. And say low is 84 and below. This approach permits the researcher to determine whether the target grouping variable affects the dependent variable differently at different levels of IQ, the control variable. Subgroups also use this thing called factorial analysis of variance. And this is a statistical technique that tests for interaction between the independent grouping variable and the control variable. The final type of control technique that is used in causal comparative that we like to talk about is this analysis of covariance. Analysis of covariance is a statistical technique for adjusting initial group differences on variables. What it does, it removes the initial advantage so that at the end of the study, the results can be fairly compared. So for an example, let's just say that you want to give a group or two groups a test that looks at their reading ability prior to introducing a new teaching method. So say you found that a group to be taught by method Y scored much higher than the group to be taught by method X. The difference suggests that the method Y group will be superior to the method X group at the end of the study just because members of the group began with a higher reading ability than the members of the other group. Analysis of the covariance statistically adjusts the scores in the method Y group to remove the initial advantage so that at the end of the study, as I mentioned, the results can be fairly compared as if the two groups started equally. The final step in the causal comparative research is this idea or this notion of data analysis and the interpretation. And if you remember, I said that there's two things you got to do: descriptive statistics and inferential statistics. With descriptive statistics, we see two things. We talked about central tendency and we talked about variation. And the most commonly used central tendency is the idea of mean. And of course, you know that mean indicates the average performance of a group on a measure of some variable. And then we take a look at that variation of the data around that mean or that standard deviation. Meaning, is it really close and clustered to the mean or is it really spread out from the mean? And then we take a look at inferential statistics. And there's three tests that you can actually use here. The most common one is the t-test. And the t-test is used to determine whether the scores of two groups are significantly different from one another. You could also use analysis of variance, which is a test that's for significant differences between scores for three or more groups. And finally, the chi-square is used to compare group frequencies. And that is to see if the event occurs more frequently in one group than the other. Again, I wanted to remind you that interpreting the findings in a causal comparative study requires considerable caution. Without randomization, manipulation, and control factors, it is difficult to establish cause-effect relations with any great degree of confidence. The cause-effect relation may in fact be the reverse of the one that you hypothesized. And with that said, I'm going to turn it over to my fellow classmate Jessica Marsh, who's going to talk to you more about an article that uses causal comparative research.
In looking for a peer-reviewed article that had to do with causal comparative research, I found an article from two people in Iran who were looking at a set group of students, and they were all female students, and they were looking at all students who were in science and mathematical physics. The title of the research article was comparing the math anxiety of secondary school female students in groups in public schools, specifically in science and mathematical physics. In the article, the two researchers were looking at testing anxiety of all females in one specific school district. The research was conducted in Iran. The research was only of secondary female students. One group was in science classes, and then the second group was in mathematical physics classes. The sample size was around 320 females in secondary school. For the research, random sampling was used to create the composition of the groups. It was based on the classes that the girls were already registered for. The questionnaire was used to indicate whether or not students had testing anxiety, and they used software to decipher that data, and they also included the Pearson correlation test and the t-test in their research. Their findings were that 62% of the subjects were in their second grade of high school, and only 38% of the subjects were in their third grade of high school. 68% of the subjects were in science field, and 32% were in math class. Hypothesis was confirmed by 95% accuracy. Their original hypothesis was that female students usually had more testing anxiety if they were in a math or science class. The article was written by Khatun Vikali and Sanat Al-Sadat Porazavi. The article was set in Iran, in District 2 in Sari, Iran, and the study focuses on young females in secondary school who are studying math and science classes. The research is a hypothesis that female students have more testing anxiety over math and math tests than their counterpart male students. The study shows a 95% causal comparative relationship in women having a higher testing anxiety than men. According to the article, math anxiety is one of the most important and effective and common anxiety of students in the course of study. The second tested hypothesis was not true. It was that men were higher intelligence than females, and it ended up being that women had a higher GPA or academic achievement than their male counterparts, even though they had more testing anxiety. The article started with a good hypothesis, and it was 95% correlated to the research that they found. Women do have a higher testing anxiety when it comes to math courses than their male counterparts, but the second hypothesis was not indicative of the research that they found. It, even though women had a higher testing anxiety, it did not lead to poor academic achievement. I do like the sampling size and the random sampling that they used for the test because they already used the students who were signed up for the courses and that were in the courses, and they used the anxiety of those students to benefit the research that they were looking for. The article also discussed that female students tend to have a greater anxiety towards quiz and tests and math related courses. This means that a lot of female students stay out of the science and mathematical areas. But they concluded that if the courses were more enjoyable and the students saw more of a value, it would also reduce the anxiety that female students had towards the tests. A conclusion for causal comparative research is it's useful if you're comparing one variable for one or more groups for a cause and effect scenario. Many methods for data collection are viable, and it's a quantitative research method. It's highly popular in educational research due to the nature of causal comparative being an establishment of an effect and then seeking the cause in the end. Listed here are the references for our presentation and for our peer-reviewed article. We hope that you enjoyed learning about causal comparative research, and we hope that you now understand it a little bit better. Thank you.